situation described presents a violation of the National Electrical Code's tap rules, specifically concerning the #4 conductors tapped from the #3 conductors. The 25-foot tap rule is not applicable here, as it applies to conductors larger than 1/0 American wire gauge or 250 kc mil. Let's explore several options to rectify this situation and ensure code compliance. Firstly, consider relocating the 90-amp disconnect. This involves moving the 90-amp disconnect to within 10 feet of the heat pump unit. At the heat pump unit, use a fuse disconnect. Connect the #4 conductors directly to this disconnect without any intermediate taps. This configuration ensures that the tap conductors adhere to the 10-foot tap rule, as they are directly connected to the fuse disconnect at the heat pump. Secondly, explore the possibility of using a separate fuse tap. Install a separate fuse tap within 25 feet of the 6 250 kc mil conductors. Fuse this tap at 90 amps to protect the #3 conductors. Connect the #4 conductors to the load side of this tap. This method ensures that the tap conductors are properly protected and comply with the tap rules by utilizing a dedicated fuse tap for the heat pump components. Thirdly, consider isolating the heat strips. Install a separate fuse disconnect within 25 feet of the 6 250 kc mil conductors. Use a fuse ampacity that is sufficient for the heat strips. Connect the #4 conductors to the load side of this disconnect. Leave the existing 90-amp disconnect in place for the compressor and fan. By isolating the heat strips with a separate fuse disconnect, you can ensure that each component of the heat pump is properly protected and complies with the relevant electrical codes. Additional notes to keep in mind: firstly, all disconnects should be rated for the maximum current of the connected conductors. This ensures that the disconnects can safely handle the electrical load and protect against overcurrent situations. Secondly, the use of a fuse tap, as described in option 2, is often considered tapping a tap, but it is permissible as long as the fuse ampacity is not less than the ampacity of the primary conductors. This ensures that the tap conductors are adequately protected and prevents overcurrent situations. Thirdly, the 10-foot tap rule applies only to taps made from conductors 1/0 American wire gauge or 250 kc mil and smaller. For larger conductors, the 25-foot tap rule applies. It's important to understand these distinctions to ensure compliance with the National Electrical Code. When dealing with electrical installations, conductor sizing is paramount. Conductors must be appropriately sized to handle the anticipated current load to prevent overheating and potential fire hazards. Refer to the National Electrical Code Table 310.15b16 for ampacity ratings of conductors based on their size and insulation type. In the described scenario, the #1 copper conductors are tapping off of 6 250 kc mil aluminum conductors. The #1 copper conductors are then feeding a 90-amp disconnect. After the disconnect, #4 and #10 conductors supply a heat pump. The #4 conductors serve the heat strips, while the #10 conductors power the compressor and fan. The tap rule violation arises from the #4 conductors being tapped from the #3 conductors and extending more than 10 feet without proper overcurrent protection at the tap point. To rectify this, consider the following. Firstly, install a fuse disconnect at the heat pump. This solution involves placing a fuse disconnect directly at the heat pump location. Connect the #4 conductors directly to the load side of this disconnect. This setup ensures that the #4 conductors are protected by appropriately sized fuses at the point of connection, complying with tap rules. Secondly, implement a fuse tap near the source. Within 25 feet of the 6 250 kc mil aluminum conductors, install a fuse disconnect. This disconnect should be rated for 90 amps or less, protecting the #3 conductors. Connect the #4 conductors to the load side of this fuse disconnect. This approach ensures that the tap is protected at its origin, meeting the requirements of the tap rule. Thirdly, isolate the heat strip circuit. Install a separate fuse disconnect for the heat strips within 25 feet of the source. This disconnect should be sized appropriately for the heat strip load. Connect the #4 conductors to this new disconnect. Leave the existing 90 amp disconnect for the compressor and fan. This method segregates the heat strip circuit, providing dedicated overcurrent protection and adhering to code requirements. Remember to verify conductor ampacity. Ensure that the #4 and #10 conductors are appropriately sized for their respective loads based on the National Electrical Code Table 310.15b16. The ampacity of the conductors must be equal to or greater than the non-continuous load plus 125% of the continuous load. Disconnect ratings matter greatly. All disconnects must be rated for the available fault current and the applied voltage. Select disconnects that are suitable for the specific application to ensure safe operation and protection against electrical faults. Fuse sizing is also important. The fuses protecting the #4 conductor should be sized according to the heat strip load, following the National Electrical Code guidelines for motor and appliance circuits. Avoid oversizing fuses, as this can compromise the protection of the conductors. Tap rules in the National Electrical Code, such as Section 240.21, govern the conditions under which conductors can be tapped from larger conductors without overcurrent protection at the tap point. These rules are designed to prevent overloads and short circuits from damaging the smaller conductors. For taps not exceeding 10 feet, the tap conductors must have an ampacity of not less than, firstly, 10% of the ampacity of the overcurrent device protecting the larger conductors, and secondly, the tap conductors terminate in a single overcurrent device that will limit the load to the ampacity of the tap conductors. For taps not exceeding 25 feet, the tap conductors must have an ampacity of not less than, firstly, 1/3 of the ampacity of the overcurrent device protecting the larger conductors. Secondly, the tap conductors terminate in a single overcurrent device that will limit the load to the ampacity of the tap conductors. And thirdly, the tap conductors are protected from physical damage and are enclosed in their raceway. In the described scenario, the #4 conductors tapped from the #3 conductors do not meet the requirements of either the 10-foot or 25-foot tap rule because they extend more than 10 feet and do not have overcurrent protection at the tap point. Therefore, one of the previously mentioned solutions must be implemented to bring the installation into compliance with the National Electrical Code. Consider the location-specific electrical requirements. Since the location is Brush Prairie, Washington, ensure that all electrical work complies with local amendments and regulations in addition to the National Electrical Code. Local electrical inspectors can provide guidance on specific requirements and interpretations. If you are unfamiliar with electrical codes or unsure about any aspect of the installation, consult a qualified electrician. Electrical work can be dangerous, and improper installations can lead to fires, injuries, or even death. Always prioritize safety and seek professional assistance when needed. The key to resolving the tap rule violation lies in providing appropriate overcurrent protection for the smaller #4 conductors at the point where they tap from the larger #3 conductors. Whether this is achieved by installing a fuse disconnect at the heat pump, implementing a fuse tap near the source, or isolating the heat strip circuit, the goal is to ensure that the conductors are protected against overloads and short circuits. Regularly inspect electrical systems. After making any changes to an electrical system, perform a thorough inspection to ensure that all connections are secure, conductors are properly sized, and overcurrent protection is in place. Regular inspections can help identify potential problems before they become hazardous. Keep detailed records. Maintain accurate records of all electrical work performed, including conductor sizes, disconnect ratings, fuse sizes, and circuit configurations. These records can be valuable for future maintenance, troubleshooting, and inspections. Furthermore, always de-energize circuits before working on them. Before performing any electrical work, de-energize the circuit at the breaker panel and verify that the circuit is de-energized using a voltage tester. This simple step can prevent electrical shock and injury. Use appropriate personal protective equipment or PPE. When working with electricity, always wear appropriate personal protective equipment, such as insulated gloves, safety glasses, and arc-rated clothing. This equipment can protect against electrical shock, arc flash, and other hazards. Follow lockout-tagout procedures. When de-energizing circuits for maintenance or repair, follow proper lockout-tagout procedures to prevent accidental re-energization. This involves placing a lock and tag on the breaker to indicate that the circuit is being worked on and should not be turned on. Be aware of arc flash hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails, causing a sudden release of energy in the form of heat and pressure. Be aware of the potential for arc flash hazards and take appropriate precautions, such as wearing arc-rated clothing and using insulated tools. By following these safety precautions and adhering to the National Electrical Code guidelines, you can ensure that electrical installations are safe, reliable, and compliant with applicable regulations. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. In summary, addressing the tap rule violation in the heat pump wiring involves providing overcurrent protection for the #4 conductors at their tap point from the #3 conductors. This can be achieved through several methods, including installing a fuse disconnect at the heat pump, implementing a fuse tap near the source, or isolating the heat strip circuit. Whichever solution is chosen, it is essential to comply with the National Electrical Code and local regulations, prioritize safety, and consult with qualified professionals when needed.